Imagine you're walking through, like, some tall grass in your backyard, right?
Just setting the scene.
Yeah, and suddenly you look down and you see a venomous snake just coiled right in front of you.
Oh, absolutely not.
Right, total nightmare.
Yeah.
So instantly your heart starts hammering against your ribs, you break out in a cold sweat, your breathing gets incredibly shallow. It's just sheer terror.
The classic fight or flight response.
Exactly. But think about those physical symptoms for a second. The racing heart, the sweat, the hyperventilation. That is actually the exact same physiological reaction your body has when you look down and realize you are holding the winning lottery ticket for, I don't know, $10 million.
Oh, yeah, that is a very good point.
So the question is, how does your brain know the difference between sheer terror and ultimate euphoric joy?
Man, that is like the ultimate biological puzzle.
Yeah.
Because we tend to think of feelings as just weather events rolling in,
Yeah.
Like a rainstorm of sadness or a burst of joy.
Right, like it's completely out of our control.
Exactly. But under the hood, human emotion is this highly complex, slightly glitchy supercomputer, just trying to make sense of the world. And today, I'm going to take on the role of the lecturer to sort of guide you through this intricate machinery.
Which is perfect, because that means I get to be the student. I'll be, jumping in, pulling apart the theories, and basically asking the exact questions that you, listening right now, are probably trying to figure out.
I love it. So for today's deep dive, our foundational syllabus is section 10.4 of chapter 10 from Psychology 2E.
Awesome.
And look, it's dense material, but it is going to completely rewire how you view your own mind.
I'm ready. Where do we start?
Well, before we get into the heavy hardware, the textbook drops a fundamental distinction right out of the gate. People use the words emotion and mood interchangeably every single day.
Oh, sure. I mean, I do.
We all do. But to a psychologist, they are two completely different beasts.
Wait, really? I always just assumed a mood was simply, like, a longer emotion.
It's a bit more nuanced than that. The difference really comes down to intensity and intention.
Okay, break that down for me.
So an emotion is an intense subjective state that is intentionally triggered by an experience. And that experience doesn't even have to be a physical event happening in front of you.
Like it could be an internal thing.
Yeah, exactly. You could be sitting in a perfectly quiet, empty room, start thinking about, say, a historical war, and suddenly become intensely sad. The stimulus is your own thought, but the emotion is a direct conscious response to it.
Okay, that makes sense. The emotion has a specific target. It's like an arrow hitting a bullseye.
Yes, perfect analogy. A mood, on the other hand, is prolonged. It's a less intense, affective state, and it completely lacks that direct conscious intentionality.
So it's just kind of there.
Right. You might wake up in a bad mood and not really know why. It's just a background hum. Emotion is the loud chord struck by a specific event, and mood is just the ambient climate.
Emotion is the reaction, mood is the climate. I actually really like that. So, lecturer, if we look at that acute reaction, the emotion, what is the actual order of operations?
What do you mean?
Well, let's go back to my snake in the grass. I see the threat. Does my body physically react first, or does my mind feel the fear first?
You've just stumbled into one of the oldest chicken or egg debates in psychology.
Really?
Oh, yeah. Section 10.4 walks us through this fascinating historical progression of how we've tried to answer that. It starts with the James-Lange theory.
James-Lange, okay. What's their take?
According to them, the body absolutely reacts first. You see the snake. Your sympathetic nervous system immediately initiates physiological arousal.
So my heart pounds, fight or flight kicks in?
Exactly. The James-Lange theory asserts that only after that physical reaction happens, your brain recognizes the pounding heart and labels it. You feel fear because your heart is pounding.
Wait, but that brings us right back to the lottery ticket problem.
Oh, so?
Well, a racing heart and sweating could mean I'm terrified of a snake, or it could mean I just won the jackpot. If physiological arousal is completely generic across different experiences, the James-Lange theory doesn't explain how my brain knows which specific emotion to feel.
Boom. That exact logic gap led researchers to the next major idea, which is the Cannon-Bard theory.
Okay, and what do they say?
They argued that physiological arousal and emotional experience happen simultaneously, but independently.
Like two parallel tracks.
Exactly. You see the snake, and your heart races at the exact same time that your mind feels fear.
I mean, I still don't buy that it solves the underlying problem, though.
Why not?
Because the brain still has to figure out why the body's revved up. There has to be some kind of interrogative step in there.
Right. You are naturally arriving at the exact conclusion modern psychologists did.
That brings us to the Schachter-Singer two-factor theory.
Two-factor, like a login.
Kind of, yeah. They argued that emotion requires two distinct factors: physiological arousal plus cognitive appraisal. Cognitive appraisal. So, like, thinking about the situation.
Right. It is all about context. And they designed an incredibly sneaky experiment to prove it.
Oh, I love a sneaky experiment. Walk me through it.
So Schachter and Singer brought a group of men into a lab and injected them with epinephrine, adrenaline.
Whoa, okay.
Yeah, this instantly caused bodily changes mimicking a fight-or-flight response, racing heart, jitteriness, rapid breathing. But they split the men into different groups.
Did the guys know what they were being injected with?
That is the crucial part. Some of the men were explicitly warned. They were told, hey, this injection will make your heart race and your hands shake.
Okay, and the others?
Others were either told there would be no side effects at all, or they were given fake side effects, like being told their feet would itch.
Oh, wow. So you have a room full of guys whose nervous systems are absolutely firing on all cylinders, but only half of them actually know the chemical reason why.
Right. Then the researchers put these men in a waiting room with a Confederate.
An actor working for them.
Yes, exactly. And this actor would either behave wildly, euphorically happy, like throwing paper airplanes laughing, or they would act incredibly angry and frustrated, complaining about the experiment and stomping around.
Oh, I see where this is going. Let me guess. The guys who knew the adrenaline was making their hearts race just sat there and watched the actor act crazy.
Spot on. They felt nothing out of the ordinary because they already had a cognitive label for their physical arousal. They just thought, it's just the injection.
Right, right.
But the men who weren't warned about the side effects, their bodies were revved up, they had no explanation for it, so they unconsciously looked to their environment for context.
Wow.
If the actor in the room was happy, the uninformed subject suddenly reported feeling incredibly euphoric. If the actor was mad, the subjects reported feeling genuine anger.
That is wild. They basically outsourced their emotional state to the room because their brain was desperate for an explanation?
Exactly. The cognitive appraisal constructed the emotion. They used the context to interpret a totally generic physical feeling.
So wait, if that's true, if physiological arousal is so generic that a person can't tell if they are angry or just full of adrenaline, what does that mean for lie detector tests? Polygraphs rely entirely on physical arousal, right?
They do, which is why Section 10.4 explicitly states that the validity and accuracy of polygraphs are highly questionable.
I always suspected that.
Yeah. I mean, a polygraph measures heart rate, respiration, and sweating, but there is no specific physiological pattern for lying. A polygraph is just measuring if your autonomic nervous system is stressed.
And you could easily be stressed simply because you're strapped to a terrifying machine being interrogated about a crime.
Exactly. The machine cannot tell the difference between the fear of getting caught lying and the fear of being falsely accused.
That totally makes sense. Okay, so if context and cognitive labeling shape our feelings so heavily, what happens if we actively try to hack that system?
Hack it.
Yeah, like if I physically force a reaction, does my brain just follow along?
Oh, you're talking about the facial feedback hypothesis?
Is it a real thing?
Very real. The theory proposes that smiling doesn't just display happiness, right? The physical act of smiling can actually create it.
The ultimate fake it till you make it.
Literally. The textbook highlights some fascinating research involving Botox.
Wait, Botox? Really?
Yes. So depressed individuals receive Botox injections to paralyze their corrugator muscles. Those are the muscles you use to frown.
Oh, wow.
Because they were physically incapable of frowning as intensely, they actually reported feeling less depression. Their brains were receiving less physical, sad feedback from their faces.
That is unbelievable.
It gets better. Another study found that if you experience something mildly pleasant and you force a massive ear-to-ear grin onto your face, you will genuinely feel happier about that trivial event than if you had only smiled naturally.
So the physical face is feeding data back to the brain's emotional center.
Correct.
But what about the brain tricking itself without any physical movement, like purely internally?
That leads us to researcher Lisa Feldman Barrett and the constructivist theory. And this is, honestly, a paradigm-shifting way to view your own reality.
I am intrigued. Hit me.
Barrett argues that emotions are not pre-programmed entities built into your brain at birth.
Wait, what?
Yeah, You aren't born with a dedicated sadness circuit or anger circuit. Instead, emotions are constructed predictions based entirely on your past experiences.
Constructed predictions. I think I need a concrete example for that.
Sure, let's take a purely physical sensation like a churning stomach.
Okay.
If you are standing inside a bakery smelling fresh bread and your stomach churns, your brain uses that context and its past experiences to predict that this physical sensation means hunger. You literally construct the emotion of hunger.
Okay, I follow.
But if you have that exact same churning stomach while sitting in a sterile doctor's office waiting for the results of a serious medical test, your brain predicts a totally different meaning. It uses the hospital context to construct the emotion of worry or anxiety.
Two identical physical sensations, two completely different emotions.
Exactly.
You know what it reminds me of? It's like the predictive text feature on a smartphone.
Oh, interesting. How so?
Well, you start typing a few letters, and the phone guesses the rest of the word based on what you've typed in the past and the context of the sentence. The brain is just trying to autocomplete our physical sensations based on where we are.
That is a brilliant analogy. Yes, the brain is an autocomplete machine for reality. It is constantly predicting what you should feel to save processing power.
But lecturer, surely the brain doesn't always have time for this cognitive autocomplete process, right?
What do you mean?
If I'm driving down the highway and a semi-truck suddenly swerves into my lane, I don't have time to analyze my racing heart, look at the truck, and construct a prediction of fear. I just react. Does the brain have, like, a bypass switch?
It does. Researchers Robert Sayonk and Joseph Ledoux established that there is a fast path for certain emotions, primarily fear.
The fast path. I like the sound of that.
Ledoux showed that a fear stimulus can travel directly from the thalamus, which is the brain's sensory relay station, straight to the amygdala.
Bypassing everything else.
Right. It completely bypasses the cortex, which is the higher-level thinking part of your brain. That fast path is what gives you an instant, terrifying gut feeling before your conscious mind even registers the details of the semi-truck.
Okay, you just brought up the amygdala and the thalamus. As the student, I want to pop the hood here.
Let's do it.
Walk me through the actual biological hardware. If I'm asleep in bed and I hear a loud crash downstairs, what is happening in my brain in real time?
Okay, so we are looking at the limbic system. That's the neural network involved in emotion and memory. When you hear that crash, the sound first hits your thalamus. Think of the thalamus as the central switchboard, right? It routes sensory information to the appropriate departments.
Sound registered, routed. What's next?
It's immediately routed to the amygdala. The amygdala processes emotional information and assesses threats. And it actually has two key subdepartments.
Oh, getting technical.
Just a bit. The basolateral complex handles classical conditioning, so it attaches emotional value to things. It flags the sudden loud noise as a severe threat. Meanwhile, the central nucleus regulates your physiological response.
So the amygdala sounds the alarm.
Right, and it signals the hypothalamus. The hypothalamus is the enforcer.
Beat enforcer?
Yeah, it activates your sympathetic nervous system. It slams on the gas pedal, flooding your body with adrenaline, dilating your pupils, and jacking up your heart rate.
Okay, so we have the thalamus, amygdala, hypothalamus. What about the hippocampus? Where does that fit in?
The hippocampus integrates your emotional experience with cognition and memory. It's the part of the brain rapidly cross-referencing the crash. It's asking, wait, did we leave the window open? Is the cat knocking over the kitchen trash again? It tries to give context to the alarm bells the amygdala is ringing.
Wow. It's like a whole security team inside your head. But if the hippocampus and the amygdala are constantly learning from these experiences, does that mean our environment can physically alter the hardware itself? Like, can repeated stress physically deform these brain structures?
Prepare to have your mind blown.
Oh, I'm ready.
The textbook details some profound studies on rat pups that prove early environments physically rewire the biological hardware. Researchers took newborn rat pups and paired a specific odor with a painful electrical shock.
Okay, sad, but I see where this is going.
Naturally, through classical conditioning, the pups learned to fear the odor. Their amygdalas lit up with intense activity whenever they smelled it.
Right, obviously. You shock them, they fear the smell.
But here is the critical twist. If the rat pup's mother was present in the enclosure during the electrical shock, the pups actually showed a preference for the odor later on, and their amygdalas showed zero increased activation.
Wait, what? Are you serious?
Dead serious. The presence of the mother completely overrode the biological encoding of pain. It physically changed how the amygdala processed a painful stimulus, turning trauma into a preference.
That is staggering. The mother's proximity literally short-circuited the fear response.
It's incredible.
But, okay, what happens if the environment is hostile rather than comforting?
The physical rewiring is just as dramatic. In another study, rat mothers were given insufficient bedding for their nests.
Which stresses them out.
Exactly. This environmental stress caused the mothers to become anxious and abusive, spending significantly less time nursing and caring for their pups.
Oh, no.
And the pups who experienced this early life abuse were much more likely to exhibit depressive-like symptoms in adolescence. And when researchers looked at their brains, they found abnormally increased activation of the amygdala.
The early trauma permanently hypersensitized their emotional alarm system.
Exactly.
You mentioned PTSD earlier. Does trauma physically shrink or damage human brain structures in the same way?
It does. Individuals suffering from post-traumatic stress disorder show marked reductions in the volume of the hippocampus. The trauma actually decreases neurogenesis, which is the brain's ability to generate new neurons in that area.
So the memory center literally shrinks.
Yes, but the deeply hopeful part of this research is that neuroplasticity goes both ways.
Oh, thank goodness.
Right. Studies show that following effective therapy and behavioral improvements, the volume of the hippocampus can actually increase back to normal levels. The brain is highly adaptable. It can heal its own hardware.
That is incredibly comforting. But man, if all this internal hardware is constantly firing off amygdalas, sounding alarms, hippocampi cross-referencing memories, nervous systems flooding us with adrenaline, why aren't we all just walking around screaming or weeping in public all the time?
That is a very fair question.
Like, how do we interface with the outside world without short-circuiting every social interaction?
We rely on a complex system of broadcasting and filtering. The primary way we broadcast our internal states is through facial expressions, but we filter them through cultural display rules.
Cultural display rules, so unwritten societal guidelines.
Exactly. They dictate when and where it is appropriate to show certain emotions.
Like keeping a straight face during a serious meeting, even if you're like furiously angry.
Precisely. For example, research shows that individuals from the United States frequently express negative emotions like fear, anger, or disgust in the presence of other people. But Japanese individuals prioritizing social cohesion might only display those intense negative emotions when they are completely alone. The rules of display are entirely cultural.
Right, but the expressions themselves, the physical way a face looks when it's angry, is that cultural too? Or is a smile just a human smile everywhere?
The physical expressions are universally human.
Really? Universally?
Yes. Charles Darwin originally theorized this in the 19th century, but it was proven definitively by a researcher named Paul Ekman. Ekman traveled to New Guinea to study a preliterate man living in complete isolation.
Oh, wow.
Yeah, this man had never seen an outsider, never seen a movie, never been exposed to global culture. Ekman asked him through a translator to make faces based on specific scenarios like, your child just died, or you are angry and about to fight.
And let me guess, the faces he made matched ours perfectly.
Identical. Along with studies showing that congenitally blind individuals, people who have never seen a human face, make the exact same facial expressions for joy and sorrow.
So it's hardwired.
It proved there are 7 universal emotions.
Oh, let me guess. Happiness, sadness, anger.
Yep. Happiness, surprise, sadness, fright, disgust, contempt, and anger.
That is fascinating. But wait, if those 7 expressions are a universal, biologically ingrained language, what happens when someone's translator is broken?
Like when they can't read the broadcast? We see that clearly in autism spectrum disorder, or ASD. A defining characteristic of ASD is difficulty navigating social interactions. And research suggests this stems largely from an inability to decode that universal language.
Oh, I see.
Individuals with ASD often have difficulty recognizing the emotional states of others and distinguishing between different nonverbal expressions, and it is equally difficult for them to broadcast their own emotions through varied tone of voice or facial expressions.
It is a fundamental disconnect in the receiving and transmitting equipment of emotional language.
Right.
Which would make trying to navigate a normal social setting incredibly overwhelming.
Absolutely.
Well, that brings us to the final piece of the puzzle. Even if you can read the room perfectly, you still have to control your own internal chaos. How do we regulate these intense feelings?
We use emotion regulation. And a vast majority of this happens without us even realizing it, through automatic emotion regulation, or AER.
Automatic, so it just runs in the background.
Right. It's non-deliberate control. Think of it like riding a bicycle. You developed the physical schema for balancing and pedaling years ago, and now your brain just executes the program without conscious thought.
But do we all ride that emotional bicycle the same way? Like, think about the listener right now. If they get a really stressful email from their boss, what are the different ways their AER might kick in?
It generally splits into two different strategies: covert and overt. Covert strategies happen entirely inside your own head.
So internal stuff.
Yeah. This might involve automatically shifting your attention away from the stressful email, or internally telling yourself, it's just a job, it doesn't matter. It's internal cognitive shifting.
And the overt strategy.
Overt strategies involve physical actions or interacting with other people. An overt strategy might be instantly calling a friend to vent about the boss.
Guilty.
Or, on a much more negative spectrum, pre-gaming with heavy alcohol consumption to numb the anxiety before having to face a stressful social event.
Is one better than the other, like mentally?
Yes. Research by Aldao and Dixon highlights something crucial. The overt emotional regulation strategies, the physical actions you take in the real world to cope, are significantly better predictors of psychopathology than internal covert strategies.
So how you physically act out your regulation tells a much stronger story about your mental health.
Exactly.
Lecturer, I think it's time we drop the formal roles for a minute because we have covered an immense paradigm-shifting amount of ground today.
We really have. I'm ready. Give me the summary.
All right, let me see if I can summarize this journey for the listener. We've learned that emotions aren't just weather patterns that passively happen to us. They are an incredibly complex, interactive web.
Right.
You have raw physical arousal. You have cognitive labeling and the predictive text of your brain desperately trying to construct meaning out of that arousal. You have actual mutable brain hardware like the amygdala and the hippocampus that physically changes shape based on your trauma or healing. And you have a biologically universal language of facial expressions broadcasting this entire internal symphony to the world.
That is a phenomenal summary. And, if there is one central takeaway for the listener to internalize, it's the sheer power of cognitive appraisal.
Context is everything.
Exactly. Theories like Schachter-Singer and Barrett's constructivism prove that. That means you have a surprising amount of power over your own reality. If you can actively choose how to relabel your physical arousal, if you can tell your brain that the churning stomach isn't worry, but is actually excitement for a new challenge, you can literally shift your own emotional experience.
You are not just the passenger, you are the driver. But before we wrap up today's deep dive, I want to leave you, the listener, with one final provocative thought to mull over on your own.
Well, let's hear it.
We just talked about how our brains construct our emotions based on context and past experiences. And we learned that recognizing universal human facial expressions is absolutely vital to our social survival.
Yeah, the 7 universal emotions.
Right. So, what happens to the human brain as our interaction becomes increasingly relentlessly digital? If an entire generation grows up communicating primarily through glowing screens, text messages, and flat emojis, rather than face-to-face interaction, could that fundamentally rewrite the predictive text of the human emotional experience?
Wow. That is a brilliant and honestly slightly terrifying question to leave them with.
Thanks for diving deep with us today. Keep questioning your reality, and we'll catch you next time.